Today we're going to talk about properties of tangents. The tangent to a circle theorem states, a line drawn tangent to a circle is perpendicular to the radius of the circle drawn to the point of tangency. So as you can see here, we would say that PR is a radius and AB is the tangent line. So R then would be the point of tangency. So that means that AB is perpendicular to PR, the radius, at point R. So that's what that says. And then we can also draw this triangle that you see right here. So that means that triangle PRB is a right triangle. So the measure of angle PRB equals 90 degrees. And the measure of angle PRA also equals 90 degrees. It's on the other side. So for these examples, it says, is AB tangent to the circle C? Explain how you know. So we know that, again, the radius should be perpendicular to the point of tangency. So that would make a right triangle. So the way that we can explain how we know whether or not this is tangent line AB is to use the Pythagorean theorem. And so we're going to do 3 squared plus 4 squared should be equal to 5 squared. So we're just trying to figure out, is that true? So 3 squared is 9 plus 16 equals 25. So 25 equals 25. And that checks out then. So yes, AB is tangent and that means that triangle CAB is a right triangle, proven by the Pythagorean theorem. So let's go ahead and look at number 2. We do the same thing for this problem. So we have AB, we're trying to figure out that's tangent. So CB is the radius at the point of tangency. So we have 9 squared plus 15 squared should equal the hypotenuse squared, which in the hypotenuse in this case is across from the right angle, which is 18. So if we solve, we get 81 plus 225 should be equal to 324. So we're just trying to figure that out. Is that equal? So when we add these together, we get 306 is equal to 324, which we know is not true. So no, AB is not tangent, and triangle CBA is not a right triangle. All right, so let's look at these examples. So these examples says BC is a radius of the circle C, and AB is tangent to circle C. So we want to find the value of x. So now they're telling us that it is a tangent and a radius. And so we're going to find x. And of course, to do that, we're just using the Pythagorean theorem. So the hypotenuse, of course, is across from the right angle always. So we have x squared plus 96 squared equals 100 squared. So we get x squared plus 9,216 equals 10,000. And so then subtract the 9,216 from both sides. And we get x squared equals 784. We have to take the square root of that, and don't forget the plus or minus. And when we take the square root of 784, we get x equals plus or minus 28. But of course, when we are doing this, we can't have a negative length for a side, so we know that our only answer is positive. So x is equal to positive 28 would be our solution, because again, we can't have a negative length. So looking at question 4, you can see that right here, that is the hypotenuse. So we have 45 squared plus 108 squared should be equal to x squared. So 45 squared is 2,025 plus 108 squared is 11,664 equals x squared. So when we add those together, we get 13,689 equals x squared. Take plus or minus the square root of that. And we get plus or minus 117 equals x. But again, we can't use a negative length, so x is equal to 117. Why don't you guys do number 5 on your own? And you can check your work with the online answer key. All right, tangent segments. The tangent segment theorem states if two tangent segments are drawn from the same point on the exterior of a circle, then the tangent segments are congruent. So we have over here in this picture AT, which is a tangent line, and AN, which is also a tangent line. So they are tangents from point A. Thus, AT is congruent to AN. So when those are tangents, that means that this distance from here to here and this distance from here to here are congruent. And the way that we show that is we make a little mark right here showing that those are equal. So looking at these examples here, we are figuring out, in this case, what JM is equal to, which is this length here. So for this, I guess we're assuming that JK and JM are tangents. So that means that this length and this length should be equal. So this would be equal to 12. Looking at question 7, same thing. So these would be the tangent lines, and it's a little off on the circle, but they should be hitting there and there. So that means that these two lengths from the point of tangent T to the point where they intersect are equal. So we set x minus 21 equal to 63 and solve. And then for the next one, same thing. These should be equal. So we are going to set those equal and solve. So we have 5x minus 4 equals 2x plus 2. So we want to combine our like terms. And when you solve for x, you get 2. So now that we know x is 2, we want to find jk. So jk is this length right here. So we have 5 times 2 minus 4, which of course is 10 minus 4, which means this is 6. And jm also has to be equal to 6 because they are equal to each other. And you could always just double check. 2 times 2 plus 2 will give us 4 plus 2, which of course is 6. All right, looking at question number 9. So for this one, I'm assuming we are, it doesn't say, so we're going to solve for x. So that means these should be equal lengths. So 2x squared plus 5 equals x squared plus 133. So when we solve, I would combine my like terms on either side of the equal sign. So we get x squared plus 5 equals 133. Subtract the 5. Take the square root. This doesn't give us a perfect square. So since it doesn't give us a perfect square, let's do a little factor tree. So we know that's 64 times 2, and that breaks down into 8 and 8. So that makes a group of 2 to take out. Of course, you can simplify that further, but it's not necessary since you know it's already going to come out of the radical. So plus or minus 8, because when you take the square root, you do plus or minus your answers, because we have x equals, I should have did the square root of 128 is what we were breaking down. So that's the work over there. Sorry about that. So plus or minus 8 root 2, because that didn't make a group. So of course we don't have a negative length, so x is equal to 8 root 2. All right, looking at the next one, it says find angle Kps. So K to P to S would be this angle here, given that angle PKS equals 46 degrees. So this is 46 degrees. And we know this length and this length have to be equal to each other. So because these are equal to each other, remember that means that triangle PKS is an isosceles triangle. And so remember for isosceles triangles that the conditions are two sides are equal and two angles are equal. So if that's 46 degrees, that means that this angle here, KPS, and this angle here, angle S or PSK, have to be equal. So we know that the angles in a triangle add up to 180 degrees. So if we have 180 degrees minus 46 degrees, and we divide that by 2, that should give us our answer. So that means that those angles are 67 degrees. So the measure of angle KPS is equal to 67 degrees, which also means that, of course, PSK is also equal to 67 degrees. And looking at the last problem, number 11, says find the measure of angle MPS, so M to P to S, given that SMO is 119 degrees. So SMO, of course, is on this side. So we're saying that's 119 degrees. And of course, we know these two lengths are equal to each other. So PO we have is a straight line. And so remember that these are supplementary angles. So we can figure out what the measure of PMS is. So angle PMS equals 180 degrees minus 119 degrees, which gives us 61 degrees. Let's zoom in a little bit on that. So that is 61 degrees. And so for this, we want to go ahead and solve. If we know these two sides are the same, or no, those aren't, that's not, I'm sorry, those two sides are not the same because it's not a tangent line. I was thinking this was tangent, but it's not. So that means that this, what is this? PS is a tangent line, and that's a radius. So that means this makes a 90-degree angle. Sorry about that, y'all. So that, remember that rule where they're equal is only for two tangent lines hitting at the same point. So for this one, that means this is the right angle by that first theorem that we talked about on the front side. So if we want to solve for this angle up here, we know we're just using the triangle sum theorem. So that means the measure of angle MPS equals 180 degrees minus 90 degrees minus 61 degrees. So that means the measure of angle MPS is equal to 29 degrees. And again, that was because we had a radius, which was MS, and tangent line, which was PS. And it is, remember, perpendicular at the point of tangency, so at S in that case. And that is all for our properties of tangents.